So share again. Is that visible now?
Yeah, yes.
Thank you. So we are going to understand Kubernetes. We you to okay, you future. Why I'm saying this is we will gradually understand why this particular big statement is being said over here. Now, where in this DevOps tool chain, because you must be wondering how many tools do we need to learn everything? Is the 20 that
Devanshu,
yeah
we cannot hear
we
you very properly.
okay, just give me 1 minute. I don't know this actually I am outside my hometown and I have come to my daughter's place. Maybe there is some issue of the power over here. So sometimes that is causing a problem. Now, is it a bit clear, Mr. Menon?
Bit clear, yeah.
Okay. Let me try, keep on trying because it is the problem right now over here. Anyway, so what I was saying is, where do Kubernetes fit in? So you see, this is the cycle of DevOps life cycle. Okay, there are various almost all the phases of a software development life cycle, where you will also find after deployment or during the deployment, where do you deploy and where do you maintain your application? That you have deployed it over onto some orchestration tool or to some platform where it needs to be maintained because you have deployed your microservices. As we are heading towards microservices, containerization. So Docker has played its part into containerization. Now, where do you put in your applications, microservices? You need some area, some architecture, and Kubernetes comes in your rescue. So this is the phase that is operate, which is mostly under the operations team, will come the Kubernetes. Does it mean that you need to be an operations guy? No. Does it mean that you need to be a development guy? No. Does it mean that you need to be a testing guy to be able to work on Kubernetes? No. The first and the foremost thing is that you need to be a DevOps guy. Nobody, because the job role of a DevOps guy will specify that you will need to maintain or deploy or monitor the Kubernetes, the microservices that you have deployed, how is the health of that and everything. So it plays a very, very vital role in the total application deployment and maintenance and monitoring. Please let me know your questions as we go on. So where and how we chalk out our plan to move up in that ladder of DevOps journey. We have started, and I think most of you have understood why we are learning DevOps. Because otherwise, if you do not take the first step, these steps are eluded. You will not be able to, scale up your career. So what comes next? Next comes advanced DevOps and SRE. Advanced DevOps, what are they? There are, like, you might be interested to learn Kubernetes more, or you might be interested to learn a service mesh, which is Istio and so many other things, GitOps maybe, as well as SRE, site reliability engineering. In India and in US, in Europe, people have come to understand, because the more and more the industry is getting matured, because many companies have adopted DevOps and they have implemented DevOps. They are recruiting people who knows DevOps because all the processes are getting agile, and with agile, we have used the DevOps tools to be agile. Okay, but now they will not be stopping at this level. They are going to monitor, maintain, automate all the processes further and further. So here comes, so as more and more applications are getting deployed, okay, more and more is the need of orchestration tools and the SRE tools, because the life of the software guy or a person in the IT department becomes more and more complicated as more and more microservices or applications getting deployed every day in and day out. Okay, so how will you know what particular out of hundreds and hundreds of applications running, and it is a multi-glot application? You know what is multi-glot application? That means one application is having multiple platforms. That means it is not only Java application. It can be Python application to start with. It is an ingress controller. Then ingress controller is faced with a Python application, the gateway. And then there is your microservices API gateway. And then there is the Java applications. There is a Postgres or MongoDB database. Then there is your, you name it, .NET applications, Perl applications, Go language applications. There are, you name it, because it is not necessary that your applications will be of uniform nature. So whenever there is a multi-glot application, you will never know which application has gone wrong or which microservice was down. For that, we need a very stubborn and very well-tested SRE. And finally, you graduate, because now all these things, with all these things comes the question of security. You have done the DevOps, you have implemented DevOps in your company. It has gone up to implementing Kubernetes orchestration tool with service mesh. Those are very good. Then you have implemented SRE, everything is fine. Then not only maintaining the health, you have to also go and be concerned about the security. So you must graduate yourself to DevSecOps and cybersecurity. Is my voice clear? A bit. So we move ahead. Then this is one of the things that market data, definitely we need to be aware what's happening and where are we standing? Are we in the right path? Are we in the right track? Are we learning the things that are actually in demand? So for that, we have a study from some a very respected research group called Gartner Group. They had produced this particularly top 5 skills in demand. This is research work done till 2023 May. Okay, out of which we find that 46.46% is people who must know Linux. People need to know Docker. People need to know shell environment. A shell environment is bash shell. People need to know, and this demand is getting. This is 23, and we are sitting on in the middle of 24. So we should. The demand of Kubernetes have gone up. Okay, so at that time it was this one. And of course, you need to, everything would be based on the cloud. So these, you cannot deny that you must need to know all these things. And can you see development or engineering background, they have a highest demand of 23%, whereas next comes the DevOps or the person knowing SRE. And you will not be knowing SRE without knowing DevOps. So it is either or, and it can be said and. If you know DevOps as well as SRE, that is the best combination. It is very high. And you can see the total vacancies as per LinkedIn, and the average salary for Kubernetes jobs, more or less. Kubernetes is designed by Google, so you can give all the credit of getting this fantastic orchestration tool to Google, and currently maintained by the Cloud Native Computing Foundation. So when it comes under CNF, CNF is a big a standard body. So any tool that comes under direct purview of CNF, Cloud Native Computing Foundation, you can rate this product. Is an open source container orchestration. So we have learned about Docker container, and you have to do the orchestration. The orchestration network or the system will help you to manage the Kubernetes, the microservices. It helps in automating application deployment, scaling, and management. Management important when you have perfected. Your development has been perfected, your delivery, your testing, your deployment has been perfected. Now is the time for your maintenance and management of the deployed application. Okay, and that is not very simple. It needs a lot of planning, a lot of knowledge on the orchestration tool like Kubernetes. Now, what can Kubernetes do? It can do a lot of things. I have listed a few important which have been adopted by. Basically, the buzzword here is the deployment. You see, the main concern of deploying hundreds and hundreds of microservices is whether are they reliable? Are they going to be available 24/7? Are they not going to break down? Are they going to impact the other microservices that are running in that ecosystem? All these questions come into mind. And whether you want to deploy, whether you want to roll out, and what will happen to the previous deployment, whether you have a downtime, or will you roll back, or you have a downtime, then you roll back and then deploy again? No. Customers today need an application to be running 24/7 all the 365 days. So where is your scope of deploying it? Like you have to stop it, because our mindset was like we had a downtime, then we deployed because we don't want to be disturbed. So most of the deployments happened in the middle of the night when the customers are sleeping. But remember, customers nowadays do not sleep. 24/7 is the waking period. Any time is an application access time. Okay, so I that rollout with a downtime. These things are part of which Kubernetes or the orchestration will take care. Resource bin packing, inbuilt service discovery and auto scaling. See, resource bin packing is you have to manage your CPU and the memory. That is one of the nightmares which the developers, the testing guys, the operations guy faced. Okay, but this you can leave it on Kubernetes to manage. Inbuilt service discovery and deploy hundreds. Earlier days, you one or two applications. You know what you are calling, which is the service that you are calling. But now you are deploying thousands and thousands of microservices. How will a particular microservice can be called, and who will discover that service? There should be some automated process. As a customer, I do not need to worry about. I want a particular function. I would like to call for that function. through a REST API or something like that, I am sure I'm going to get the response. So within that mesh of thousands and thousands of microservices, I need my particular application, and that too, I do not want to wait. It should be immediately available. The response time of my query, there is a tolerance level. There is an SLA. So the companies are very, very concerned with that SLA, that what is my SLA, service level agreement? That is, what is the performance expected? How many requests will be processed per second or per milliseconds? So all these things come into picture, and who is going to help me with the discovery of that service? Service means your application. So that is where Kubernetes pitches in. We can also work with the heterogeneous clusters. Clusters are the main thing. There will be a lots of hundreds and hundreds of nodes. How will those nodes talk to each other, and whether they are, who is going to maintain that those huge bundle of nodes? And these nodes are not scattered in a particular premise. It is scattered all over the world, over the cloud. It is not a matter of joke to just be aware of or to maintain those heterogeneous clusters. And the thing comes persistent storage, because you are working from anywhere of this of a particular part of the world, but you need the data. We are all working towards the data. How do we store the data? How do we access the data? How fast that data can be accessed? And most importantly, because that is a data, it is to be very, very secured. I will not allow any other person to get an access to that data, because the data should be very securely persisted. Who is going to do? Again, it reaches in. Okay, high convenience options, that is, you can scale it according to the, because during the Christmas time, the hits, number of hits, that is, many people are buying things. So naturally, there will be a auto scaling towards upscaling. And during the summer time, not summer, I will say during the peak time of the winter, when the sales go down, there may not be that much of a sales. So it will be automatically descaled or downscaled. But this should all happen towards, I mean, the load sharing will be happening automatically. So there are basically these are the 7 important reasons why industry has adopted Kubernetes. Industry, I mean the computing industry, the computing world, all the companies, the big 5, okay, have adopted, because there is a market study and they find that there is the simple app, okay, microservices, lift and shift. You have to have a facility of moving the on-premise applications to the cloud, and with least of effort. Cloud native network foundation functions. This is a very important part, because that is the body. So all the networking functions are governed or ruled by this particular. So machine learning, heavy computing, CI, continuous integration, continuous delivery. All these 7 compulsions of the industry has pushed in for the industry adopting Kubernetes. Are you getting me? Any questions, please do not hesitate. So what is the role of Kubernetes? You see, the day we learned about Docker, we had discussed about monolithic app. It's the application that you have the backend, the database. Backend is the business logic, and the data which will interact with the business logic, and the business will only have the access to the database because that database is has to be sacrosanct. Okay, and this needs to be securely within one application layer. But these are very tightly coupled and they are not independent. They are not independent. So what is happening? We have moved out of this structure and went into microservice application. Now you see, this is the user. User is going to hit the front end. Front end is going to hit the back end. Back end is going to hit the database. Database is going to store the data. Okay, and there are number of microservices which are doing the entire thing. It is today there are 5 or 6. Tomorrow there can be 600. They are all independent functions, or we can say that these are microservices in the containers. So each one container is one microservice. They are independent, and we have seen this particular architecture. Now this is the entire orchestration. Everything should be like a well coordinated orchestra. So there is the role of Kubernetes. Kubernetes is the maestro. You know, you have gone to an opera and there you will see somebody standing in the middle of the orchestra, and he is called the conductor. He is conducting the entire music. Even the smallest to small instrument is tuned as per the instructions given by that conductor. And that conductor for that orchestra or orchestration is called Kubernetes. So all these microservices, the containers, which we know as pods, will be working with the help of the instructions given by the control plane of Kubernetes. That is what we are going to learn a bit, if not in most details, but yes, we are going to learn at least the way we should be knowing the theoretical background of Kubernetes. And there are many containerized services which are waiting to be deployed. So your deployment should be well coordinated. It should not happen that you are deploying something and you are making something which was running fine, making them down. No, you cannot afford to do that. It has to be very well coordinated, well planned, and seamless, smooth. These are blue-green deployments. These are called rolling updates. Something you are rolling in, roll out, but using rolling update feature of Kubernetes. The need for a container orchestration tool. Trend from monolithic to microservice, already know that. Increased usage of containers. Yes, everyone is putting their application into containers, and because the containers are very easy to deploy. Somebody was asking, do we need to understand deployment? Yes, that is the part which Kubernetes handles very well. Yeah, you are going to be the DevOps guy who needs to know how Kubernetes behaves, or what is the architecture of Kubernetes. How will you use the power of Kubernetes to deploy your containers or microservices? And they should be well managed within the cluster of network of Kubernetes. Okay, that is the thing that you have to learn. So there can be microservice A, microservice B, microservice C, microservice D, N, Z. So all these are microservices, but they have to be well coordinated. If this microservice goes down, I have to immediately replace this with a replica. How will I know? I'm not part of this network, and I do not need to. My company does not need to be always manually going and checking the health of each and every microservice. Is it possible? Yeah, if you had 1 or 2 microservices, that's okay. You have designed a process where your operations guy will go and keep on monitoring with the help of a script that whether how is the health of that two microservices. But when it is coming to thousands of microservices, is it possible to monitor manually? What do you think? Do you need something to help you to monitor the health of the cluster? Because if this particular small component of this cluster goes down, you say there are 999 microservices running fine. How does it matter if one particular application goes down or one particular container goes down? But very sorrily, I have to say that maybe at that point of time when this microservice has gone down, a particular user is looking for that service. So what will be the experience of that user? He went in with a great hope that he will be able to use this function. Some payment, maybe a payment gateway has gone down. So the customer was trying to buy a product, but he was not being able to pay for the product that he has ordered. And so what is the experience? Was the experience good? Because he could not pay for the order and therefore the order is not purchased. Will the experience be good? It doesn't matter because it is one customer, does it? Will the company think like that? That out of millions of customers, only one customer was affected? That is good. If out of millions of customers, it is only one customer, no. So the probability of between the millions of customers, there are thousands and hundreds of thousands of customers who are looking for this application, and this application is down, and you do not have any means to know that this application is down. And when you come to know that it is down and you take your steps to rectify this, already the customers have been dissatisfied. They have given the customer satisfaction rating of that company has gone down. There was a lot of social media impact that no, I'm not happy with this service. They are not good people. They are providing us with some fake promises, but they actually will, they do not provide, because maybe there was a bumper sale at that point of time. The window was open for only 2 hours. Okay, within that 2 hours, there was an Apple, Apple laptop that was on sale, and it is huge discount was given, almost 80% discount was given, and millions and people were hooked onto that website during that 2 hours period when the sale would be done. Okay, but at that prime moment, this application, this particular thing has gone down. So what happened? Nobody was, even if somebody has ordered it, but they could not purchase. You see, hundreds and thousands of people have got dissatisfied. And they say that this guy, this person, that particular application or this company is just a fraud company. They are just making us hook into that website, but for no use, because they do not have the capacity to serve us. That was a fake propaganda. Okay, will it be good for your company to get that thing? No. So my expectation is that, yeah, anything can go wrong. With that I would need to provide a mechanism immediately when this thing has gone down. My system should know that this thing has gone down and I should be able to replace it immediately with the same replica. Not even if it is a database, I will have to replicate the same database with the same data. Data should not be lost. It is not a very simple thing to design and to maintain. So Kubernetes comes into our help, but we have to know how to use the services provided by Kubernetes. So high availability or no downtime, scalability or high performance, discovery and recovery, backup and restore. All these are the features of orchestration tool. I'm not getting any questions. Is that I'm very good in explaining, or is that I'm very bad? I'm not being able to at all explain anything. Before I go to Kubernetes in details, can I expect any question, or shall I proceed? Or may I know if I'm audible? Is that screen visible? All these questions come in my mind because I'm not being able to
All is
see
good,
you.
Dada.
Okay, thank you, Tamzida. I hope you are Tamzida. Okay, fine. So let us now focus a bit on the architecture. If you can understand this architecture, my 50% of my work is done. So can we endeavor to learn this or to understand this? Where do we start from? Do we start from this end or this end? Okay.
Developer end.
Developer end. Fine. That's good. So I am a developer. I'm a DevOps guy, or maybe a developer or an operations. So I'm just given an actor. This actor is a developer, just any name. He can be a tester as well. Okay, testing team, development team, your operations team or DevOps team. It is coming, some query is coming, getting some instructions are coming to, this is the Kubernetes cluster that we have designed or we have created. We are going to create a Kubernetes cluster like this, where this is a master computer or the master node. I can say this is, can you see this is master node? This is one machine, one server. This server can be on premise, bare metal, or it can be on the cloud, or it can be virtual machine, anything, whatever you say. But it is a server. Okay, this is the server. This is the master node. And maybe this is one worker node, another worker node. So how many machines are there? How many servers are there? How many nodes are there in this cluster? I have a cluster of one master server and two slave nodes, or better to say worker nodes. Worker nodes, why we say worker? Because they carry out the instructions given by this control plane, or we say master node. It is a slave to this, to the master. Okay, anyway, we in a very good Kubernetes cluster, you say you can have more than one master node, and of course you can have hundreds of worker node. These are nodes where your jobs or your applications, your containers should be running. What are the containers? The containers are nothing but your application, like Java application, your Python application, your .NET applications, or maybe a sort of a glot type of application where you have multiple platforms of applications. So these are on the worker nodes. Can you see? Let us discuss about the flow. So there is some utility which is also provided by Kubernetes. We have to install that kubectl. Okay, with the help of that, kubectl is a very powerful tool. Now, nowadays you will find the user interface, the user UI to this Kubernetes cluster. That UI can be provided by a third-party tool or can be provided over the cloud. There are cloud applications like the Google Cloud, Amazon Cloud, Azure Cloud. They provide you an interface to work with their Google Cloud engine, so GKE, or Azure Cloud, Azure Kubernetes, cluster, so services, so AKS, and for Amazon it is called EKS, which is Elastic Kubernetes Service. Anyway, that user interface you can do graphically. You can work with this master, with the Kubernetes cluster graphically. But my dear friend, you must always remember, knowing something graphically is good, but it is always better to know through the command line. Command line is the power. that you get. That's why it is called PowerShell, or that's why it is you say command prompt or CLI, command line interface. Okay, so we must learn few commands on the kubectl utility through which we are going to interact with the master node. The master node is consisting of the main part, which is the API server. We are coming to each and these are the components of Kubernetes cluster. The API server, anywhere from anywhere, this is like your the prime minister or president of a country. So anything and whatever, now if everything will work according to the mandate or directives from the API server. So the entire thing will come to the API server. API server will work on the instruction. Okay, and then it will use the etcd. Etcd is the key value store. We will come to discuss everything. It will discuss with the cloud controller manager. Now this is a dashed, an arrow. Why? Because this may not be in use every time. It is only in use whenever you have to interact with the cloud provider. Like there are cloud provided services. When you do that, then you interact, API server will interact with that particular, like as I told you, GKE or AKS or EKS. Then you interact, the API server interacts with the cloud controller manager. Okay. And then API server will also interact with the scheduler. Scheduler will in turn schedule all the pods or the containers, or it will distribute the load to the kube proxy or the kubelet, and the kube proxy will distribute that load between the nodes and the containers or the pods. And there is the controller managers. These components are the important components, 4 important components. And along with the cloud controller manager, there are 5 important components of a control plane called the master node. This is the manager. Without a manager, the entire, or you can say this is the conductor. The conductor will conduct the entire orchestration. And out of this is the maestro, the conductor, the maestro, the maestro of that orchestra, API server. Without an API server, so if something goes wrong with the API server, the entire control plane will go down. So I need to have the API server also stored as a replica into the ATC. This is a fantastic architecture. So immediately, if there is some problem with the API server, immediately the replica will take place or replace. So you can say this is 24/7. It is available, highly, very high performance and availability. HPA. Okay, scheduler, and every information should come and get stored over here. And this API server will access that information. This information is nothing but about the health of the entire orchestra or the cluster. So each and every pod. Now we come to the worker node. Okay. So what did we learn from master node is that it controls the entire orchestration. Nothing can go without permissions coming from API, authentication, authorization. If that kubectl command is the correct one, you can use the CLI or API or some dashboard, which is the UI. Okay, but most of the 99% of Kubernetes administrators or DevOps engineers who are working on Kubernetes will work on the kubectl. Anyway, we come to the data plane. It is called the control plane, and the worker nodes are called the data plane because all the processing will be happening over here. So the worker nodes cannot be of mean configuration. It has to be a good configuration machines, because you are running hundreds and hundreds of applications over here. So the CPU, the memory and everything has to be very, very much. The resource must be there is a resource limit, and you can control the resources again with the help of Kubernetes configuration files. I told you one day that everything you code it, you code your infrastructure, that is infrastructure as a code or infrastructure as a service. You code your configuration. So what is that called? That is called the Ansible or the Chef or the Puppet. You are coding the configuration. Similarly, you code your orchestration. You will do some configuration files, you will code, and those are called, somebody asked about the artifacts. Now these are the artifacts, the manifest files, the declarative files, the declarative scripts that we write for the deployments and everything. Okay. I think this is a very important tool for Kubernetes. When you install Kubernetes, you will install Kubelet as well. Okay, this is the master components. You have to install all this, as well as you are going to use the Kubelet. You will install this one, as well as the kubectl and the kubeadm, kubeadmin. So the kubeadmin will install your architecture, your cluster. So once the kubelet is one thing which will maintain the health of the containers. These containers are nothing but pod. Can you see there is something small written pod. So in the worker node 1, there can be one pod. One pod means one container. It is a thumb rule is that within one pod, you must not store more than one container. But you can always have more than one container in one pod, but it is not a right design. Right design is to have as many pods as you want, but do not have more than one container inside one pod. What is pod? What is this thing? We will come to that. Don't worry. We have two sessions, right? So this is the container runtime. So this engine, the container runtime engine, the CRI, the container runtime interface, which is the container daemon, or basically you say the Docker daemon. Docker, I'm not saying Docker because it is not necessary you need to install Docker only, because there are other containerization tools. So better to say container D. You do not need to mention the tool name, whether it's Docker or Mesos or Rocket, or for that matter, any other containerization tool. So container D. So this is the container runtime, and you see these are the Kubernetes objects. What are these? We will learn this. These are various objects that we are going to. So with the help of these objects, we are. This is one more thing which is that you will install along with the kubelet on the nodes. This is not going to happen. Kubelet will not be there on the API on the control node. The kubelet and the kube proxy will maintain and will immediately know what is because it is sort of a network manager within the node. So it can immediately discover whichever container has gone down or whichever pod has gone down. So it will propagate that news to the API server. API server will store that state in the etcd. So through that etcd, with the help of the API server, it comes to the scheduler. Scheduler will go and directly, because it knows what is the container, it has gone wrong. So through the kubelet, the pod manager is the kubelet. So the kubelet, through the kubelet, scheduler will schedule the pod, scale the pod If that pod has gone down, so please replace this. It is like a bypass surgery. Not bypass surgery is not a right term. You are saying that replacement surgery. Something has gone wrong, replace it. Your car wheel has gone wrong, replace it immediately. If that can be automated, that is the best way, but that is unfortunately very manual. But here it is very automatic. Once this pod goes down, this information will come through the kube proxy and it will go down to the API server. API server will store that state information into the etcd, and etcd will pass this information to the scheduler through API server. Scheduler will go and hit that particular, will replace this particular pod. Is that flow clear? It will come through many of these objects that we have. We will create these objects. Is that more or less that flow? How this orchestration takes place? How something will be immediately be known to the scheduler through the controller manager. Okay, we are going to come to this. So what is the utility of kubelet? Can anybody tell me? Kubelet, kube proxy is on the worker node.
Yeah, I had a question. So what I was trying to understand. So
Yeah.
if any pod goes down,
Yes.
like the pod is kind of like it one pod contain container, one container, as you mentioned.
Yes.
So
Yes.
that
And that container contains what?
The container contains image.
Oh, fantastic. Very good, Tamjida. I'm very happy.
Definitely.
Image is the application. Yes, yes.
Image is the applications. Yes. So that is the question. So if one pod goes down, so that image will go down. So that application, in that application, only that part will be go down, or full application will be go down?
No. Full application does not go down because we are not using monolithic application. First of all, we are using microservices. Each of these microservices having a separate isolated function. They are not, one microservice is not dependent on the other. But yes, one microservice can talk to the other microservice. There will be a link.
Okay,
all these containers can talk to each other, or the pods will talk to, there is a pod networking. All these things are there. It's a very complicated architecture, but that is the beauty. If you can challenge yourself to understand this complicated thing, you are the masters. You can rule this industry.
Got it. Thank you so much.
So your question is, I thought that you were asking, how is this going to replace? Is it, or is it going to impact the other services? No.
Is it going to impact the other services?
No, because each of these, there are 12 rules. Those are called very important rules of how do you make a microservice application. It is not that somebody can start doing a microservice application. It has to follow certain 12, microservice rules. If you follow all the 12 rules, then you have perfectly made one microservice. If there is any dependency of this pod with this pod, then that is not a perfect microservice. If this pod going down will make this pod down, then this is not a perfect architecture. I mean, you have not designed your microservice correctly. So none of the microservice should be, they are loosely coupled. They are not tightly coupled. That means one pod going down will not impact the other pods in the environment. And one pod going down will be immediately let known to the API server. API server will sprung into action. Otherwise, it is not doing anything. It is time and again, it is checking the etcd. Etcd plays a very important role. That's why, can you see there are two etcds? One is replica of the other. See, these are all components. Any component can go down. These are physical things, objects. This component can go down. If etcd goes down, even if API server, scheduler, controller manager, everything is up, entire master node will come down. It will start malfunctioning. It will not come down as long as API server is up, but API server is not being able to get anything from here. It will be a big headache for API server to conduct the entire orchestra. Okay, so what they have designed, that it is preferred, thumb rule says you should not have one etc database, etcd database. You should have at least one more replica. Those are the internal designs. You do not need to take care. Kubernetes takes care of that. So versatile it is. It knows each and every what can happen. Okay. So each of these things are well managed. Let me go ahead. More and more things will get clear. Now, I can approach my architecture from any end. I can come from the end user part, or I can come from the development part, or this thing from the control plane. If I am coming from the end user is my end user, the user. So end user will fire a query because he wants to access one pod or one service, one application. Okay, what will it do? It will use a browser, isn't it? How will you access it? How do we access any application? Through the browser. We will say a REST API or whatever it is. It will be hitting a load balancer. Now that can be an ingress load balancer or a load balancer which is proprietary to the cloud. Generally, we go for the ingress controller because we are implementing, because the load balancer, if you implement it from the cloud, whether it's AWS or Azure, it's going to be costly, very, very costly. It will cost you a lot of money. So why don't you, as a DevOps engineer, you are recruited because you will implement your ingress controller, which is also a load balancer. And one of the very famous ingress controller is the Nginx controller, the reverse proxy. Yesterday, or the previous weekend, I told you if you can go and look into what is a reverse proxy and a forward proxy, which is Nginx. So whatever it is. So Nginx is a load balancer as well, that ingress controller. Anyway, so what is happening? This load balancer is distributing the query or the traffic according to the load of this cluster. This is a cluster. Okay, you can see the cloud provided network edge. So if the load balancer is provided by the cloud provider, it's fine. If the company goes for that, that's okay also. But elastic load balancer or whatever the load balancer, but it's going to be very efficient, but it's very costly as well. So it will distribute the traffic according to the load. It can understand with the thing. And not only that, it will go and discover the particular pod. For the sake of clarity, for simplicity, there is one pod. But my dear friend, please remember, in a server, in a one node, there can be hundreds of such applications running. They are all up and running. They are running for last 1 year. They are not down. They are all available. So how will this end user end up hitting the right pod is the problem of this load distributor or the load balancer going to hitting a particular Kubernetes service with the help of kubelet and the services. The service will discover that particular pod that the end user has requested. Okay. So there are system services which will help the kubelet maintain its health. See, kubelet is all these things: kube proxy, kubelet, API server or the kube server, the kube scheduler. All these things are also pods. You might wonder how it is, how beautiful the design is. Everything is a pod, because everything is a service, is an application. These applications are running inside pod as a pod. etcd is also a pod. They are getting run by the container runtime. So even the master panel or the control panel, we need to install Docker or any other container D services. Remember, so we need to install Docker. If I may be allowed to use Docker, it is Docker. And here also on each of these nodes, you need to have Docker because everywhere containers are running, pods are running. You may wonder, you see, this is a pod, Kube API server. This is a pod maintained by Kubernetes. Everyone is a pod. So the pod communication, that there is a pod networking. So I will give you a nice thing. Maybe not this one. Today we need to understand the architecture, the theoretical background very well. Maybe on the next weekend we will discuss about some hands-on. How do we install this? Hello.
Actually, what is a pod? And
what is a pod? We will discuss. Yeah, we are going to come to that slide.
okay.
Of course, I understand that when you are encountering this term pod for the first time, it is a bit confusing.
Yes.
I'm not saying Kubernetes is a very easy topic to know over a night, over a day. It takes a lot of hard work, lot of good understanding. Then only, and lot of a good teacher like us to explain the architecture, explain the theoretical background, explain the hands-on. Then you will get the entire picture very clear. And once, see, main people in a hurry, they try to learn few examples, this and that, and they appear for the interview. But most of the cases, more often than not, you will miserably fail in the interviews. I'm not making you scared. It's not my interest. As a teacher, I never scare anyone. I always welcome people to understand the subject very well. Because I believe if you understand the architecture, the technology, you are going to speak well in front of the interview because you have a lot of confidence. You know how things happen inside. Because most of the people use the graphical interface, they do not know and they are not concerned what is happening inside. But my dear friend, please remember, in an interview, interviewer will going to be asking what is happening inside, not how you are doing it, how things are getting done inside. If you know that logic, that flow, I'm very sure you can score very well. And actually you can scale up see, it is not only learning a subject, it is also the roadmap. Because if you do not understand this, you will not be able to scale up your knowledge to learn further things. So you must know what is a pod and how pod networking happens, how you install the architecture, how each and every component interact with each other, what is the role and thing of each other, of each of the components. All these things are very, very important. I'm just discussing of the flow, that when somebody wants a particular service, every other component start helping that end user to reach that destination, to access that application. Okay. This way.
Sorry.
Yes.
So you expect that the queue proxy informs the API server when a pod goes down, and the API server connects, the scheduler gets the information from etcd API server. Now, what's the role of kubelets?
Kubelets, very good question. Yes. See, there is a lot of, differences, but the main difference is the kubelet will maintain the health, or rather, the kubelet itself maintains the health of the pod. Like the scheduler will interact with, say, suppose a pod has gone down. Let me go back to this. Say a pod has gone down. Okay, this pod has gone down. So the kube proxy, with its ability to understand with the help of, this is a network utility. Okay, with the help of this, it will immediately come to know about that something has gone wrong with this pod. There is an interaction between this pod, which is kubelet, and the kube proxy. Kubelet, because kubelet has the primary first-hand knowledge of the health of the pods. So kubelet will have that information within itself. Kube proxy will just ping. Ping means, or rather, send a heartbeat to the kubelet to understand whether everything is fine. So kubelet has that information that no, this particular pod with this particular IP address or this particular service of that port is not working. Okay. Now, through some network architecture, this information will come to the API server. API server will store that information, or rather interact with this, because in the meantime, kubelet as well as kubelet does not give the details of which pod and this thing, but kubelet will give an information to through the API server and get it stored. So whenever the kube proxy comes to the API server with the same information, API server will look into that etc and will found yes, because both of them are complaining about something has gone wrong. It cannot, so there is a serious issue. So it will validate that yes, that information is already available. So we will spring into action. So what will it do? It will immediately instruct scheduler to go and please do something about it. Scheduler is a fire brigade. The fire brigade has that information. There is some fire inside this particular worker node. First of all, this information has every detail of that pod, because that pod is residing on a particular node. So how to access this is the portion, this is the action of scheduler. How to go about and get it replaced immediately. This pod will be replaced by the replica, and there is a controller manager. See, every part is working in orchestration. It is not only scheduler. Like the kubelet is working along with kube proxy is working along with the API server is working along with the etcd is working along with the scheduler, and the scheduler will also use the controller manager's capacity to replicate. So there is a replication manager, replication manager, because you have to replace it. So there is a replica of that pod also running. So you will just pick up that and put it over here. That's all. Did I answer your question in short?
Yes, perfectly. Thank you.
Thank you. But the flow, is that flow more or less? Because many people don't understand this flow. They are not separate entities.
It is very clear. It is very clear.
Okay, very good.
Quick question.
Yeah.
My question is this, right? So we know most of the pods run in each of the worker nodes that you just showed, right? So what if the worker node itself goes down? So how does it get replicated, or how does a new pod, how does a new worker node spins up? What's a function of the Kubernetes cluster spin of the new worker node?
Yes, very good question. So suppose, it's a fantastic question. I didn't expect this question in the very beginning. Okay, very good. I will try to explain it as far as we have learned. So let's say this is a worker node. There are two nodes, two servers. Each of them is having these pods. These pods can talk to each other, as well as there is an intercommunication between the worker node 1 and worker node 2. So we will establish a pod networking. along with the master server. So there is a pod because everything is a pod. So the master also need to communicate over the pod networking to a particular pod, isn't it? So let's say, as you said, your worker node is down because this is a physical server. It can go down. Now, what will API? Immediately, this information is available with the etcd through some mechanism. Okay, through the kubelet and kube proxy. And there will be replications. Or what will happen is that the scheduler will schedule all these pods. What is important? Is the kubelet important, kube proxy important, or this containers important? What is more important to you? I will say there is much more importance for these pods rather than to save this server. I will save this server, okay, but these pods are first thing first. I have to take these pods from here to here. This is a working node which is running perfectly well at that point of time when this worker node was down. Because then the controller manager, that the replication controller will come into picture. What will it do? Along with the scheduler, it will schedule all these pods to be available through the pod network into the worker node 2. So here there are 3 pods. Now there are 6 pods running on the same server. And there will be an auto scaling of the CPU. So all these things are architecture based. That's why they pay a lot of money to the architects. So these are the very common features. That means if something goes wrong, yes, you always have to design your architecture with the worst case scenario in mind. You should not be happy planning it. Happy planning is the optimistic planning that everything will work. Everything is working fine. Your planning should be when everything is not working fine at all. What should my architecture do? Did I answer your question a bit?
Yes, sir. Thank you so much.
Okay. Yeah, in this situation, if you say my worker node got crashed, okay, at the same time, my control panel has also, a plane has also gone down, then there is a disaster. It is very unfortunate, but this is very, very rare. That's why people in a cluster, they have 2 master node, exact replica. So this etcd will be replicated onto the another master node. So everyone has an information of the other. So if this node is going down, if this master server is going down, it will be picked up immediately by the other server. So in this cluster, you have 2 master servers, 2 master nodes, and maybe say 20 worker nodes. Are you happy? And even you can do this, that out of the 20, actual physical servers are 10, and the rest 10 are the replicas. Replica of the node. I'm not talking about the pods. So it's a very fault tolerant system or architecture that you have designed. These are done by big organizations because that takes a lot of money. But more important is if you do not lose your customers, valued customers, your high availability is more important than your capital investment. Yeah, you invest, but your investment should get a return of investment as well.
So Debashi, sorry, is a cluster housing an entire application or just a part of an application or more than one application?
you say the cluster. Yes, cluster is also an application because you have to install the cluster. You have to implement that cluster. So that application is nothing but Kubernetes. With the help of Kubernetes, which is a tool, orchestration tool, which is an
Sorry, you
application.
didn't get the
Yes.
question. Like, for example, is the cluster housing like an application for selling goods on the website, or how do I want to understand what a cluster does with an application. Is it housing an entire application or parts of an application? For example, a retail website application. How?
Retail.
I'm just a bit
Those are,
confused.
yeah. Those are the containers or the pods. The application,
so
when you say, they are services that are getting provided as retail services, like a departmental store or maybe a e-commerce site. Now that is what you have implemented as a microservice application, which has been deployed over the cluster, Kubernetes cluster. This has been deployed, but this kubelet, kubeproxy, this controller manager, etcd, these have been installed. They are, you can say, they are like, what to say? You are seeing that you are running, a athlete is running. Okay, 100-meter. So a sprint. Somebody is running like a dynamite. But internally, you clap your hands. You are very fascinated with how good that application or that particular person is running. Okay. Usain Bolt, maybe he's running 100 meters in less than 9 seconds. Great achievement. But the muscles, the internal heart, the lungs, the stomach, the very bone structure, skeleton, they are playing in the background for Usain Bolt to run that particular 100-meter sprint below 9 seconds. Did I make that particular analogy more or less? So what you are seeing is the Usain Bolt running. He's a good runner, getting the first prize. Okay, but to support Usain Bolt to run that 100-meter sprint, there is a lot of things in the background that is helping Usain Bolt run. So if, let's say, the API server gets down when the container runtime was running beautifully, suddenly you can see Usain Bolt falling on the track. So he will not be able to, I'm sorry to say that example, but I wish him all the best. But let's say he could not complete the 100-meter sprint because something has gone wrong, which was supporting in the background, the architecture. So this architecture was provided with Kubernetes. Your application is something which you have deployed after this architecture has been established. As a DevOps engineer, our part is to establish the architecture with Kubernetes. And
so,
then,
correct me if I'm wrong, Mr. Devashish. Are you telling that this is like a fail-safe methodology, that if something goes wrong, it will can resolve the issue or replicate the issue or replicate the solution and
yes,
and keep the application up and running, right?
yes, that is what we will design. That is, these are the objects we are going to see. We have established the Kubernetes cluster. We will deploy the application, but also at the same time, we will design the Kubernetes objects. Can you see? Just give me 1 minute, please. Just 1 minute. Hello. Sorry. Okay. Yeah. Tell me. So, Mr. Menon, you were asking something.
I'm just not asking. Like was telling that is it a fail-safe methodology by which we can assure that application will always be up and running. If there is any issues with the server, it can automatically detect and resolve the issue by itself, right?
Yeah, you have correctly pointed out it's a fail-safe mechanism. Okay. The thing is, it is called fail-safe architecture. Okay, that means you will have the redundancy resolved. So something failing will be automatically will be put into replaced, or something will be taking over to make that mechanism as fail-safe. You are correct. It's a fail-safe mechanism such that it is highly available, HPA, high performance and highly available. So performance and availability is a very important term. You should not take much time to replace this pod, and we will demonstrate it how fast it can be. I will implement a very simple Kubernetes cluster with one master and one node. Okay, and in my local system. So how good is that? You can do it in your laptop. You can implement a Kubernetes cluster within your in your laptop, and you can see all these mechanisms working. We will do that most probably in the second session on next week. Any other question you have? Please feel free to do this. Now, I'm giving an architecture overview. Architecture is very important. You see, there is the controller manager. There can be this is another, as I told you, everything is a pod. So there is a replicated pod. There are two pods working with each other. So if one thing goes down, the other will take place, and it will be immediately replaced as well. So let's say Kube Controller Manager is interacting with the cloud. So there will be a cloud connector. And this API server, everything will have to connect to the API server. It has to report, like you are the project manager. So your project team members have to every time report back to you. So it is like API server is the project manager of the entire project, which is the Kubernetes. API server will interact with its etcd, which is the database. So that's why you have the shape of a database. And what is the database? It is not a traditional database like the RDBMS. It is not. It is a key value store, which is mostly the in-memory database, the memcached, the in-memory data, because the in-memory databases are very fast database. It does not need to remember the history of what happened earlier. It has to remember what is happening now. That is called the serverless processing. You do not need to know the history. Okay. So if something is happening right now, please take an action right now. What happened 2 days back doesn't matter. Hello. 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 Was there any question?
Ranjit's mic is on, that's why. Ranjit Kumar.
Oh, okay. So can I proceed? So you see that this is the Kubernetes nodes, which are the worker nodes 1, 2, 3, API server is interacting with the kubelet as well as the kube proxy. Both kubelet, kube proxy, kubelet, kube proxy. Each of these nodes have to have kubelet, kube proxy, and what else? Can you tell me? Kubelet, kube proxy, and
the path
and the container D or the Docker. Okay, so these are a must. And Kubernetes, when you install Kubernetes and join these nodes over onto your with the master, then the nodes have to join to the master. Otherwise, they are not a part of the cluster. Okay, we know how to make them join and talk to the master. So the kubectl, that interface, the CLI should be available over here. So kubelet, kube proxy, kubectl, and Docker. These are the 4 utilities or components of Kubernetes that must be present on each node. So what are the master node components? etcd, API server, scheduler, the controller manager. Controller manager is having, you see, all these things on the very base layer is the controller manager. And you can say that there is a Docker or a container D. So this is the master node. And on the slave node, sorry to say slave, but actually it's a worker node. So there is a Docker, kubelet, kube proxy. Nowhere I'm saying kubectl because kubectl is a CLI interface to Kubernetes. That is a part of Kubernetes, but that is you have to install it, and it will be installed when you install Kubernetes automatically. Okay. Any questions on this slide? So these are the Kubernetes components. Now, again and again, I'm going through the same thing again and again, such that it is ingrained into your head that this is nothing else. This is the picture. So I have the master node. This is the Kubernetes architecture or the Kubernetes cluster in which I have a master node and the node components. So there will be, when I install Kubernetes, there will be the API server which will interact with the scheduler, with the controller manager, and etcd. It is hosted or on the top of Kubernetes Linux. Remember, Kubernetes is available for Linux and Windows. So generally, when you work in an organization, you are going to work on Linux. So Kubernetes master must, because the Linux servers are much more stabler and much more, stubborn and versatile, highly available in comparison to Windows. So Kubernetes master runs on Linux because they have to run day in and day out without stop. They cannot afford to be down. And the components, node components, which is on the node, slave nodes or the worker nodes, are kubelet, container runtime, and the kube proxy. So etcd. Now I'm coming to each of the components. What is the time left? Okay, how much, whatever I can do today, and on the next weekend we will continue with the further discussion. And next weekend I will try to, whatever we have learned on the first day today, and continuation 1 more hour. After that, the rest 1 hour we will see a demo that will make things clearer, much clearer. So what is etcd? It is a distributed database. etcd is the most important component of the master node. All the configuration changes that we are making. So see, everything is getting stored. It is like somebody is monitoring with a spy eye what is happening to the entire architecture, and there is a mechanism to store that information. Okay. All the configuration changes that we are making through the manifest file. Manifest files are the artifacts of Kubernetes. all the configuration changes that we are making, all the deployments being created, all the scaling operations being performed, all the details of those are stored in etc database. It's a fantastic database. This is the backbone of the master node. Though API server is the most effective part, you can say this is the heart and this is the brain. If this is the human body. So the desired state is stored in the distributed database etcd. It is recommended to have 3-5 replica sets of this. I was saying about 1 and 2, 2 replicas. They are recommending that at least 3 to 5 replica sets of this etcd in the cluster so that the information on the desired state is not lost. It is like the Terraform state. So that's why GitLab stores the Terraform state in the internet, somewhere in the backend. The backend state is, we have learned that. We have to constantly discuss all these things because technology is very important to understand. It is not that you have learned Docker, forget it. Now I will go to learn Kubernetes. No, again and again you go back to Docker, understand what is containers, images. How do I put that image into a container? Because if you can do that, then you step into Kubernetes. That is the bigger picture. So all Kubernetes cluster configuration details, secret keys, you see, secret keys, passphrase, passwords, etc. stored in whatever the secret information, which are not supposed to be exposed to the outer world. Only the API server, not even the controller manager, not even the scheduler, not even the container D will have an access to the data provided by etcd. It is so much sacrosanct. And see, it is only accessible by API server. So API server is the brain. Brain runs the heart, but without the heart, the brain cannot function. It is so much related. One cannot access the etcd directly as it is designed in this manner. So from outside, you will never be able to access etcd. You cannot hack the data inside. If you can hack someday, that's why you need to know cybersecurity, DevSecOps, how to prevent hacking of the etcd database of a Kubernetes cluster. Now we come to the API server. We have already understood what is an API server. It exposes Kubernetes API. Kubernetes API is the front end for all the Kubernetes control plane and is used to deploy and execute all operations in Kubernetes. So as I said, this is the brain. This is the endpoint for Kubernetes. You can say this is the endpoint or this is the starting point. Both. For Kubernetes services, which gets exposed for controlling the various API services provided by master node to the slave nodes. So all the services that is provided is coming from the API server. Pods, you control the pods, you control the deployments, you control the etcd components, APIs, all pods information, etcd information access, all the pods IPs are registered to this endpoint. That you can say everything. The next important component, the second important component inside the master node is the API server, or sometimes it is also called the Kube API server because it is Kubernetes. If anyone, one thing more, Kubernetes, this is a favorite interview question. Why is Kubernetes called K8s? Can anybody tell me?
I think there is 8 words, so that's why they call it as.
What was the answer? Why is Kubernetes being called K8s? If anyone can tell me. So
It's Kubernetes, KAS.
It's the number.
yes.
Yeah, okay.
Sorry. 1, 2, 3, 4, 5, 6, 7. So sorry. There will be another one. 8. So it is called K8S. Is it clear? Because to spell out Kubernetes every time, it is quite cumbersome. So you take a shortcut, call it K8S, right?
Oh, so what is K3S?
K?
Does that have to do with spelling too? Does that have to do with spelling too?
Kubernetes.
K3S. I think there's K3S too.
K3S. What is that?
Oh, can maybe maybe
I am not aware of
maybe it's
that.
another way. Maybe it's just another way to write the K8S. I was coming across K3S somewhere too. Okay, don't worry, go ahead.
Is it? I'm not very sure. I will try to find out
So
what is.
K3S is like a lightweight Kubernetes distribution, and that
Is
I
it?
think I think that is created by or developed by Rancher Lab.
Okay, great. I will need to know about this one as well in that case. So it's
Like
interesting.
K8 is Kubernetes is you need to work with a various component and because it is very much resource intense infrastructure. But even
Yes.
if your environment does not need that much resource and your application is very short or small, then you can go with the lesser number of resource and move to lightweight version of
Kubernetes.
your Kubernetes.
Okay, like you have the Terraform Lite, similar to that, is it?
Yeah.
Okay, great. I have to find much more information on this. Thank you for your information. Great.
No, sure.
So anyway, we proceed with this. So we have learned about this API server. What about scheduler? The scheduler takes care of scheduling of all the processes and the dynamic resource management and manages present and future events on the cluster. So it is not only an arrangement to do a firefighting just at the moment when the fire is there. No, it can also take guard of the future events that can happen. Scheduler manages the scaling up of pods. So if you want, so there was a desired state of 3 replicas, but your application is getting a lot of popularity and many users are coming in to use your application. So what you thought, I will scale up the pod. Instead of 3 replicas, I want 5 replicas now. You go with the uneven numbers, 3, 5, 7, that way. Okay, so that is if an application running on 5 pods in a virtual machine of 5 CPUs and a RAM of 5 GB. So 5 pods, 5 CPUs, 5 GB, where each pod is configured for 1 CPU. You can configure when you through all these configuration files. You can do the resource management. You can limit how much a pod will take the resource and limits. So I can assign to one pod, 1 CPU, 1 GB of usage. Okay, so 5 into 1 is 5 CPU and 5 GB. Then the scaling up of the application for additional 2 pods of the same configuration, someone needs to look for a VM with available resources to create these 2 pods is handled by the scheduler. So if already you are overbooked, so your capacity is running out, that means or just at the top most utilization optimized. So 5 pods taking all the 5 CPUs, all the 5 GB RAM. Is there any more room to schedule for another 2 pods? No. So what in that case, there would be a horizontal scaling. There would be a need for horizontal scaling, which will help to scale up one more node to accommodate, or maybe if there are a cluster of nodes, then it will find out where these two pods can be accommodated. And this is the task of the scheduler to do. So this is component schedules the pods to the nodes in the cluster based on the consideration of several health metrics. So there will be several health metrics on which it will judge whether it will be I will put that particular pod into that particular node. If that node is too much busy or too much hits are happening, or rather the 80% of CPU is occupied, 80% of memory is already in use. So I will better mark that that is called tainting. Tainting and tolerations. There are two terms in Kubernetes called tainting and I will taint that node as no vacancies to further upscale. So that is called taint. And I can untaint it. I can say that, okay, I have the maximum capacity, but it can tolerate a few more. So that 80% can go to another 10% more. So I can tolerate it 10% above 80%. So 90% tolerate. So it can go up. And so if that is manageable. So those are health metrics of the nodes. It will be available to the scheduler, and with the help of that, it will schedule the pods either in that node or to some other node. Is that point clear? Very interesting thing. But it should take care that there is no conflict of CPU, RAM, available RAM or storage left. And there are also one important thing is no port conflict. It takes care of a lot of things. Controller manager. Now, this is also a very important part. Everything is very important, but the most important part is etcd. Second is API server. Then comes scheduler, and maybe this is your controller manager on the fourth. The controller manager runs all the controllers on the Kubernetes cluster. Although each controller is a separate process, to reduce complexity, all controllers are compiled into a single process. So a controller manager is one single point of contact for all these various controllers, like node controller, which will control whether you have to scale up one more node or scale down one node down. Okay, or there is a need for horizontal scaling. So node controller will be there. A replication controller. So a replication controller is like you want to replicate the pods. It is now 3. You want to scale up to 5. So 5 more, or so 2 more replication. So who will do that? Who will take care? The replication controller from the controller manager. So controller manager will inform replication controller, please, you have a lot of sleep. Now wake up and go and do that 2 more replication, that is a desired state. Endpoint controller. So this is the service delivery points sort of controller. So you will divert the traffic to that endpoint. So who will manage that? Endpoint controller. Service accounts and token controllers. There are lots of token things because the security is utmost important in this cluster. You have hundreds and hundreds of microservices, and there can be databases. There can be lots of data information. So security, everything is driven by token controllers. Even a node joining today, there are 3 nodes and 1 master node. OK, tomorrow you decide, your company decided that I will add another 3 nodes into the cluster. How will it do? So there will be some token generated on the master server, with which token that token will help that nodes to join the master. Joining the master means joining the cluster. Okay. Now on the node, We are coming on the worker node. So there is kubelet, as we have said. Kubelet takes the specification from the API server. So kubelet cannot do anything of its own. The decision has to be taken by the API server, and he has to carry out the kubelet. That poor guy has to carry out all the instructions that has come from API server and ensure that the application is running according to the specifications which were mentioned. Now, kubelet will govern or will take care of this manifest file. Manifest is that Kubernetes artifacts which you have designed such that you want replication, 5 replicas. So that is a directive given to the kubelet, and kubelet will do accordingly. But that directive will come through the API server. So tell me, anyone, that you design your deployments, your services, you are writing your declarative scripts. Where do you write? Whether you write on the node or on the master server? That can be a question. Where will you build the manifest files? The deployment files or the service files or the replica sets, daemon sets, secrets.
It has to be the master server, right?
Yes, exactly. Because what is the first point of contact for all this manifest file? Where it will give it? On the master node. Who will first have a look? Will have a review. It will be the API server. You give an instruction through the kubectl, kubectl. You can say kubectl. So that kubectl will give an instruction. That means you will build a file, a manifest file over onto the master server through kubectl, and you will apply that through kubectl, and that application goes to be considered and reviewed and approved by whom? By the API server. If the API server thinks that yes, that manifest file is correct, it will allow to build an object. So you are basically building the objects like the deployments, services, replica sets, daemon sets, secrets, config maps, so many things. Clear? So kubelet will be running according to the specifications which were mentioned. So the API server will hand over the specification to kubelet, and kubelet will do, say, let's say the kubelet has got an instruction that I have a manifest file, the deployment, where we will need to deploy a pod or create a pod with 5 replica sets. So similarly, the kubelet will deploy 5 replicas of that same pod. So there will be 5 pods of the same application running at the same time. On the where will it run? Will it run on the master server? Where will the pods be created? On the master or on the slave? Who is going to create it? The kubelet is going to create it. But where? Of course, because we are learning the node part, the slaves, the worker nodes. Okay. Never do you create your manifests or you apply manifest over in the master, but that object that like the deployment is an object, service is an object, that daemon set is an object, will be created on the node. So sometimes more than the master, your server, the slave node needs to be a powerful machine, because here your applications are running. You need to have a good server. So the kubelet is the component on the worker node. You see, it monitors the activities in the worker node and communicates the health of the node to the master node. Communicate to whom? In the master node, to which component? Kubelet will communicate the health of the pods or the node to whom in the master node?
API.
API server. Everything will start and end with API server. And more specifically to the controller manager. Yeah, everything is controller manager. Everything comes first to the controller manager, but controller manager does nothing. It is sort of a messenger. It will pass on the message to the API server. Whatever actions need to be done will be executed from the API server level. Now we come to the last component of the node, which is kubeproxy. The proxy service runs on each node and helps in making services available to the external host. So you are hitting the node or particularly a pod from where? From external, like you are giving a REST API call from from browser maybe, or from some application external outside the Kubernetes cluster. It helps in connection forwarding to the correct resources. So now it manages the resources over the network. So it is all the networking layers are built with the kubeproxy. How will it communicate with the application layer? Somebody coming and knocking at the door. Okay, somebody opens the door. So who opens the door? Kubeproxy opens the door. But the parcel will need to be delivered to the particular person in a particular area. So that person is somewhere in some room. So this kubeproxy will take that parcel and deliver it to that particular person in that particular room. There are, let's say, 40 rooms in a big house, 40 rooms, and there are 40 people staying in each of the room. How will the package be delivered to a particular person? Kubeproxy knows the destination. Kubeproxy enables port forwarding. Port forwarding is one of the most important concepts of services. See, it is not, you are not communicating over IP addresses, but you remember each and every component will have its IP address. Like the pods, each individual pod has its own IP address, but IP address will be translated into a NAT, network address translation, NAT. Those who have done computer engineering will know about the 7 OSI layers, networking layers. So there is an address translation. So IP address will be translated to some address translation, and that address translation is nothing but the service ports. Forwarding of the services to the external nodes and master. So whenever we are deploying the new pods or services, we need to forward the port to communicate to the other pods or services so that these services are discoverable to the external node, because our main purpose is to hit a particular pod for that application. So who will be the first carrier? Kubeproxy. Kubeproxy will give it to the pod, but the pod is managed by the kubelet. So kubelet knows whether the pod is particularly healthy or not, if that pod needs to be replicated or not, all this information. Kubeproxy does not have all this information. It is just a carrier. It will deliver the packet of the request. The request packet will go and get hit to the service. Kubeproxy, I can say it's a networking component. Deployments created and exposed as a service is possible for the kubeproxy. So finally, you know the container runtime. I'm not going to discuss this because you already have learned about Docker. See, the note is the Docker does not come as a default container engine. It can be any other container manager other than Docker. So it is not mandatory. That can be an interview question. That do you think always it is necessary to have Docker as your container engine? No. But there is a standard daemon called container D. So the CRI, there is a particular term called CRI. I'm not going through that details because it is out of scope. Okay, CRI architecture is there is one more thing, container runtime interface. Okay, you have to, that container runtime interface is like the standard. When you learn something like you are learning English language. So whether you in India or in Bangladesh or in Japan or in Nepal, okay, or in US, the grammar of that language remains the same. Similarly, a container technology remains the same. Only the tool can differ. So Docker is one of the tool implementing that container technology. Mesos is one of the tool implement that technology. Rocket is one more tool. So I'm not going to the tool level. I'm saying of the technology, which is the container engine. That's all. Now my question, humble question is, what happens if the master node gets down on the API server components or the API server component crashes? Will the applications running within the pod stop running? Anybody will volunteer to answer this question?
I don't think so because there is replicas already, so to just do like a failover.
Exactly. Thank you. Fantastic. I think you got in the very first day. What's the matter? Very good. Very good. So see, only an API server, if something happens, yes, some pod got down and you want to get it immediately replaced, then if the master node is down, that thing will not. Suppose there will be three replicas of a pod running. Suddenly something happened. Two of the pods got down. And unfortunately, at that point of time, the API server is also down. You are running a high risk. Your application is running because one pod is still running. But if something happens to that pod, your application is down because you were not having any way to replace those two pods which were down, because your application controller through the controller manager and the API server and the scheduler will not be able to help you schedule your pod, replace your pod. You are fantastic. No. So you have answered it no. As the worker nodes and the pods continue to run, though no changes in the node or pod configuration can take place unless master node is made up and running. So somebody was asking about the pod, but I think we have run, usually we always run out of time and there is no exception today. No worries. We will continue it in the next session. Is that fine? We will have some interesting discussion. But if you want me to continue, I can continue for another 1 hour.
I think we can continue start from the next weekend. Is it okay with everyone?
Because it is almost 2 hours, 2 hours, 15 minutes. Anyone?
Okay, small few announcement. James, your voice only we can hear a humming sound. So meanwhile, a small announcement. Our cybersecurity session is going to start from 8:30 p.m. Central Time. Those who are interested, please join. And our cybersecurity, the main training is going to start May 10th. Those who want to, pursue their career on cybersecurity domain or DevSecOps, which is highly trained in this AI market. The link is live. You can start complete your registration as soon as you can. Thirdly, our DevOps class, the main classes, our main course, job ready training, is going to start from this Tuesday. The link is live. Those who wants to join, please feel free to complete the registration. If you have any doubt or any issue, WhatsApp us. One of our team member will ping you, and they'll try to resolve those question or queries. So these three announcements from our end. Any question from you?
Sorry, for the registration, can you help us with the link?
For which one? DevOps or
cybersecurity?
Okay. Are you in the WhatsApp group?
Yes, yes, yes.
Okay, I will then post in that. So are you asking for cyber registration link for cybersecurity main course, right?
Both for the both of them, for the registration and for the main course.
Okay, okay. I will share with that.
All right, thank you very much.
Debashis, if you don't mind, I would like to have a question for you after the recording and everyone is done.
Oh, sure. Why not? I'm there.
Any other question?
I had a question because I already done the DevOps. So
yeah, you have already completed the DevOps training with us. Yeah.
I have a question. So is there any other platform where I can ask the question?
You can ask in the WhatsApp group. You can communicate with our trainer or coordinator. There, or if it is like a one, if you want to discuss it one with 1:1, then you can ping Mr. Debashish, or you can ping in our one of our coordinators number. Normally he is active in the group, or you can ping me.
Yes, can you just provide any? I already spoke to Mr. Debashish so far, but I have few question related. So if I try to contact it with the DevOps group, if you can check the text. So if I could get any coordinators link where I could contact, so I can just get some clarification, because I'm going to start the cybersecurity course too. So
Okay.
it is very important for me to communicate with someone at least to
Sure.
get clarification.
I will notify them, and they are going to ping you within before EOD. Definitely, because we do have another session for cybersecurity. I'm assuming you are.
I think, Mr. Menon, we can arrange to get Tamzida into that interview group that we have. No? That it will be beneficial for all the others also.
Yes.
If there is a technical question, something related with interview,
yes,
or
yes,
some
yes.
questions related, that will be better. It's a good forum. We get a lot of discussions over there.
So that forum agenda is we do have a 4 different domain training, and those students who are facing the interview, if they are facing any hurdle, job, visa, work authorization, technical question, whatever, there is a resume, marketing, that is a open but closed, like only those students who have already completed the training with us. Is only for them, so they can share. And normally we do have all our trainers available, few of our coordinators, and a few industry expert, so they can navigate and guide them very prominently and effectively. So yeah, I will highly recommend, if you are in the job market, please join that one and share every day-to-day activity.
So
it will not only help you.
How could I join there?
I think
we will add you. We can add you into that group.
Yeah.
Thank you so much. Appreciate it.
No problem. Sure.
Then I have a question. You said cybersecurity will start around 8 p.m., right?
8:30.
8:30 p.m.
Saturday,
Is it
today.
West African time or IST?
It is in CST.
Today,
Central
right?
Time. Yes. Today CST.
Okay. Okay. All right. Thank you very much.
Okay.
This would be the second session in the series. Cybersecurity.
Hello,
Yeah, Pradeep.
yes, sir. How to take the PPTs from the website? Could you,
Your voice is very low.
how to take the PPTs from website? I was saying.
You cannot download it because that is a restriction, restricted one. But you can check, you can read, and you will have this website access forever. Whenever you want to check the course content and the PPT, you can just log in and you can check it from there.
Okay, means we cannot download it, right?
Yes.
Okay, okay, understood. Thank you.
But for our students that who are attending our regular classes, okay, we have dedicated channels on the Teams where they can go and they can download the recording as well as lots of documents. So that is for the students. This is an internship program, so that facility is not there.
Because this internship program, we had more than 300 registration. Now people join on a topic based, and some students needs to they have joined to gather the holistic idea in DevOps. Few join to get the clarification on the particular tools. So managing a single channel is very hefty. You know, the Microsoft has very rigid access control. So it cannot. I think there are not even we cannot find a very automated way where we can add all those people in a Microsoft team channel. So normally in the classes, once they done the registration, we had to do create the channel and add all our students manually, because Microsoft team is controlled by Azure Active Directory, and that is very secure and very strong and robust architecture they follow. So we don't have that, or we could not find still now where we can create a single channel or private channel where all our internship students we can add automatically once they complete the registration. If we can find, definitely we'll because that will remove too many hassles. But
yeah, exactly.
We are trying, and hopefully we'll find some way. But still, we could not find any like dynamic or automated way. If once the student complete the registration, they'll automatically added a Microsoft Team channel. If anyone has any ideas or any overview on that, suggest us. Then we'll move, because we want, but Azure Active Directory is not letting or completing that part. Any other question?
Yeah, quick, just a quick one. Okay,
Yeah,
as a DevOps engineer,
mm-hmm.
Of all the two chains, which ones? Because like if you go into the job market and say, oh, they want a DevOps engineer, analyst, or whatever, which particular areas? Because you have so many there. You have, which particular ones that you can really focus on, that you can now master, so that when you go into the job market and you see the position, maybe they might be asking for Kubernetes, Terraform, Jira, or whatever.
See, here is I can answer you very shortly. Every project will be different. Some project you will your company or the project team is maybe they are working with Kubernetes. Some company they are working with only Docker or Docker Swarm. Some company they are only only managing with Terraform, some are Ansible. But when you face the interviewer will ask you all of this. Wow. Because this project are dynamic, even for big companies also. Even they don't have an idea that right now they are working with Docker or Docker Swarm. Maybe tomorrow they are moving to Kubernetes. Okay, now they do not want to constrain themselves, or they do not want to hire somebody only for the preferred tools which they are right now working. They also need to think that in for their future, that maybe tomorrow they will switch, but that time they don't want to discard the ongoing people and start new hiring. That will not be a efficient approach, right? So normally when you face the interview or when you see the job posting, mostly you will find they mentioned Linux, AWS or Azure or multiple, and at least these 5 or 6 tool set: Docker, Kubernetes, Terraform, Ansible, Git, GitLab, or maybe Jenkins. GitLab or Jenkins. This does not mean that that project is have all of this tool set incorporated with that particular project. Maybe they are working only 1 or 2 tools, but they are hiring because tomorrow or day after tomorrow they may shift. So same goes for development. When you see some development job position or job advertisement, they are looking for multiple JS, Angular, React, Node, various JS, but mostly they are going to they are right now working with a single framework. But why they are posted? Because tomorrow they don't know. Some new project will come, and maybe you understand the recruiter point of view and what you have. So the best approach how to overcome this situation: prepare yourself for this. So there are other tools as well in DevOps. So that is not that much, gained that much light in the market. But there is a chance that your project needs that kind of tools. So prepare yourself for these 5 tools. Now, if you face in our course, I'm giving an example. First 20 session training in our DevOps 20 session, we covered Jenkins. Then we found that GitLab is getting more attention in the market. So then we change our course and move to GitLab. What we have done at that moment of time, we created a 1-week session for all of our previous students free to upgrade from Jenkins to GitLab, because that is our moral obligation. The reason, because industry was shifting from Jenkins to GitLab. Now, so tomorrow in an interview, you find that there is a job position and they are still using Jenkins. Now you can tell that, hey, I have not worked with Jenkins because I am more into in GitLab, because their primary objective is same, and I had a long years of experience and expertise in GitLab, and that is 99% scenario. The interviewer will be convinced with this statement, because at the end of the day, they need to know that are you familiar with this particular objective. That means if the problem arise, are you familiar with this problem, and can you resolve this thing? Tools may vary, but idea and technology should be same.
Yeah, understood.
I have a question.
Yeah, please go ahead.
So, I mean, this question revolves around development side of DevOps, right? So, what if you find yourself in a situation whereby you land a job, right, as a DevOps engineer, and then the role given to you revolves around you developing maybe a dashboard or something, and then deploying it through the CI/CD pipeline, maybe Jenkins pipeline and all that stuff. How do you cope in that situation? what I'm trying to say is this, because I once landed a job where I was, you know, the role was like a DevOps engineer, but at the end of the day, the title of that position was cloud software engineer. So even though they use Jenkins and they use Groovy script and all this stuff, they wanted us to, you know, write the pipeline in Python, you know, because they said that the pipeline, they don't want people to use like shell script or much of Groovy because it's gonna be too heavy. So they want it to be lightweight using Python scripting and all this stuff. And then most of the scripts are called Python codes, and you know it was very, very difficult. So how do you come out of that challenging situation?
To answer you this question, just give a minute. Let me stop the recording first.
Okay.
Any more question before?
I have a follow-up question though. Maybe when you answer this.
Okay, I will answer this. Don't worry, because this is very tricky.